could tell me where this graph goes up and down, right? Like local max, local min. We already did this graph, right? Over here it's up and then it's down, right? It's going down, 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 then it goes back up. I'm going to draw something and I want you to see if you can tell what this is actually doing. There's a section of this graph that's the red section, then the green section, then the red section, then the green section. It has nothing to do with up and down anymore. It has to do with something else. Does anyone see it? Yeah, go ahead. You raised your hand. I heard voices and I saw your hand.
The fact that if it's concave down, it's going to be...
So you're using the word concave down.
Basically facing downward.
Do y'all see in the red section, the graph looks like part of a frown? You know, frown and smile, right? Do y'all agree in the red it looks kind of like a frown in that area, in that region? And then in this green region it looks like part of a smile? And then you're back to a frown and then back to a smile. Right? When I say smile and frown, I'm saying smile, right? Frown. This red section is part of a frown. It's not necessarily the whole frown, but it's at least part of it, yes? And then right at this little point right here, that's where it switches and you go from frowning to smiling. And then it's like part of a smile until you get to here. It's like you're at the bottom of the smile. And then now you go and turn into the right side of a frown. And now you're, let me do it, yeah. Then you're left side of a smile, right side of a smile, right? Ignore the screen. So this would be kind of the left side of a frown, right side of a frown, left side of a smile, right side of a frown, left side of a smile, right side of a smile. Got it? The second derivative tells you where your graph is smiling and frowning. Now the technical word for that is the concavity, all right? If your second derivative is positive, what do you think it's doing? Smiling or frowning? Smiling, and that's actually makes sense, right? Positive people are like happy. So if your second derivative is positive, you're going to have smiles in your graph. If your second derivative is negative, then you're going to have frowns, okay? That's the idea. So what we do next class is everything we did today, we're going to do it again, but with the second derivative. So we take the second derivative, we set it equal to 0, we find out where it doesn't exist, we do a number line, we get these regions, we get test points, but we plug those into the second derivative, and that tells us where we have smiles and frowns. Okay? So that's next class. And now you can go. Yes?
Will this be what we did today?
Oh, we didn't talk about the test. Yeah, we didn't talk about the test. Well, the review, there was a lot on the review that was like logs and exponentials. I don't want y'all to think like the test is going to be laid out that way. Look at all the different concepts in the test, and I would say that each different concept is equal. If you've got to go, I'm going to keep recording this if you have to go. I will talk about this for a few minutes, okay? But you're free to go. I'm not keeping you here. So where's that review? Okay, so yeah, the first part of this review was a couple of related rate problems, right? And I told you on the test, that's what I'm doing. I'm going to give you a few. I'm going to have you choose. Now, I'm probably going to make you do 2 of them, all right? So, you know, you might, and that'll be the first question on the test. So you might decide, hey, you know what? I'm going to just like wait and do that later. You know, just go take care of the rest of the test and then come back to that. It'll be up to you. You're allowed to bring those sheets, you know, those sheets I gave you, and then they're also on Canvas, that like the template of how to do things, and like fill out the boxes in that. You know what I'm talking about, right? Feel free to bring a few of those if you want. You don't have to. I'm not going to provide you any, all right? All right, so that's that, right? And then, you know, this is just like, I put the section here, 3.3. So what are the main ideas? Can you take derivative of exponentials? Applying, you know, product rule, chain rule, quotient rule. Can you do derivatives of logs? Applying product rule, quotient rule, chain rule, right? This is more of that, right? More exponentials, more logs. These are harder because there's like chain, like product and quotient in here. Product and quotient and chain. These are a little more direct. But there's a really important part of this one. More chain, nasty. Oof, nasty. Okay. Find the equation of a tangent line. So, can you take that derivative and use that from the very beginning, right? The main idea that we started this class with, which was find the derivative, then you use the formula, y minus y1 equals m times x minus x1. We've used that almost every test, every single test, right? Okay, the next, I even put here, this is still in 3.3. This is logarithmic differentiation, which means that the only way to take the derivative of these is to do log on both sides and then bring things down and then apply product rule. So what I don't want you to look at when you're doing this review is that, oh my gosh, this test is almost all 3.3. Don't look at it that way. I've just tried to give you like a good variety of examples, all right? You need to be able to differentiate exponentials and logs, and you need to be comfortable with product rule, chain rule, quotient rule with those. That's what this is saying to you. This is saying to you, don't forget you need to be able to do equation of a tangent line if I ask you to. This is saying you need to know logarithmic differentiation. I mean, absolutely. This right here to me is equal to every problem up here, like on a test. Like this is 1 or 2 problems on the test, and this is 1 or 2 problems. So I don't want you to not study this and focus all your attention on up there when this is, just as important. 3.5, so this is just derivatives of inverse trig functions. We spent part of a day on this, right? Y'all remember doing this? I proved these formulas to you, a few of them. You don't have to prove anything, just know how to use them again with chain rule, quotient rule, product rule. Okay, then we get to limits. This is L'Hopital's rule. So you've got, L'Hopital, this is infinity over infinity. This is 0 times infinity. This is 0 to the 0. This is 1 to the 0. So I've only given you a few L'Hopital, but it's a variety of everything. It's the most basic infinity over infinity where you just differentiate top and bottom. This right here, 0 times infinity, you have to drop one of them. And then the next the next 2, you have to do the log. So you just have to go back and look at all your notes and study that. I mean, there's a lot of concepts in there. And then I gave you plenty of these to practice, right? Gave you 4 different ones where you have to find absolute max and min on given intervals. So function, closed interval, you go tell me where the highest and lowest points on that graph are. Some of these derivatives are easy. Some of them are a little harder. Some of them are a little messy. I don't know. That derivative too bad? Product rule, right? So, and that's it, right? That's the whole thing. So do you have any questions on it? I haven't made the test, so I can't tell you how many questions there are or anything like that. I haven't made it yet, so.
Is there potential for a bonus question?
Maybe, I don't know. I might do a bonus. Maybe I'll say do 2 of the related rates and then a 3rd one for bonus or something like that. So, yeah.
Is it going to be like, you're going to give us like 4 of the related rates and then you choose 2? Or?
Yeah, that's what I'm looking to do. Yeah. And every related rate problem in this review is kind of let's see, this one right here, you need to know the volume of a ball basically to do that problem, right? Yeah, volume, right? And then this one is, well, I did this one in class. We did this together. This is the cone, and then to do this, you need to be able to use similar triangles. So that might not be your favorite, but it's there. This one was the plane, and then you drew a triangle, and then you used Pythagorean for this. And then on that one, that was a homework problem. Nobody has asked me about that problem, so I never covered a problem like that in class as well. So, but that is a problem that's like from the homework. So, yeah, just come ready Thursday, be fed, make sure you go through this. You'll be fine. You got it. Study groups, right? Study groups. Get together, help each other out. You can do it. Positive attitude. All right, y'all have a good day.
I called him to work. My son's gonna call in and I'll show him my cat. Is that what Yeah. So it's like, sorry, I have to study.
Are you gonna want anything after the test? Or like, you want to take it and see if you need more time? Do you have time after class? You do? So if we need to go a little further, we can? Okay. That work with you? Okay. All right, very good.
So should you'll be there at 8 a.m.?
No, 8:30.
Oh, okay.
On Monday?